What I'm going to talk today about is, well, I think I'm obliged to introduce you to the University of Warwick and WMG. And also, when I was sort of working out what to say in this talk, I'm always interested in looking back and seeing how we tried to predict the future in the past. So we have a little history lesson. I've had the opportunity to ask people in industry. I'm part of the British Automation Robotics Association. We had a meeting recently, and I asked people there, obviously people working in industry, installing automation in factories, selling the equipment, what they thought would be in the factory of the future. And you probably already had it mentioned today. I think as I walked in, I heard Industry 4.0 mentioned, so I felt we had to include that. And we're going to touch on the work of the Automation Systems Group within WMG and my own little research area, the mobile robotics, and look at robots of the future. And also, because a lot of my work is in education, and my role on BARA is the education and training representative, who's going to be working there as well. There's a nice little table showing you about the University of Warwick. WMG is an academic department within the University of Warwick. For a long time we were part of the School of Engineering, but we're now a big academic department in our own right. We were founded by my boss, Professor Lord Kumar Bhattacharya, and he started off with nothing more than a desk and a secretary. Still got a secretary. And his basic, simpler concept was that academics need to work with industry. We need to be solving the problems that industry face. And to do that, we have to work directly with them. And we've been doing that ever since, trying to cover this valley of death, as been mentioned before, that from the innovation to application. In addition to that, we also train and educate a large number of people, 1,500 individuals, not just within the UK, but all around the world as well. And a lot of them want to study engineering, business management type subjects. Some of them do want to study manufacturing engineering. So this is the makeup of WMG at the moment. So the reason why in your brochure it'll say Warwick Manufacturing Group, that was our old name. We just go by WMG now, simply because we do a lot more than that. So if you look at the list, obviously a large number of people are involved in the materials processing, and if you want to get in touch with any of these people, because you're working in a related area, then please get in touch with me and I'll put you in touch with them. But we also look at experiential engineering. We've got a new battery scale-up facility, so we're looking at battery technology and energy and electric systems, mainly for the vehicles, automotive industry. And we also go into healthcare as well, so looking at healthcare, so a lot of biomedical applications as well, which come in obviously in our manufacturing area. And cyber security, service systems, so looking at how this can all be implemented into the service industry and supply chain as well. So we're looking at the business aspects as well. So my area is in here, automation systems, but we also have metrology and net shape manufacturing, so machining, and the additive layer manufacturing, and digital lifecycle management as well. So history lesson then. So I use this picture because I got it off one of my colleagues. It's taken 30 years ago of Makino's flexible manufacturing system. And the idea obviously was very innovative, came about in the 60s. They obviously started from scratch. They had to create all these machines themselves to create a fully automated factory to manufacture components like, the whole aeroplane, metal parts for a whole aeroplane, for example, in one sort of cycle. So you go down to this batch size of 0 and you can scale up. and infinite variability and flexibility. And it looks a little bit old, but actually the concept is still relevant today as it was 30 years ago. I should imagine that these machines probably don't exist anymore, but their new versions are probably a bit faster, more efficient, certainly a lot more accurate. But yeah, the concept's there. Another picture I like to show to students is this one from the 1950s, showing the idea of computer, machines controlled by computers, manufacturing machines controlled by computers, and the fact that, yes, the guy who originally did the job by hand can now sit in his workshop and with his feet up reading a nice book in a comfy chair. Obviously, this is not the reality that we have, and probably isn't likely to be as well. So you can just see how we have odd views of the future. Some time ago. So, what are the opinions? So I asked Borough, what do you think you're going to be in factories of the future? And they were very good, actually. They came out with these ideas very quickly off the top of their heads. So, virtual factories, I'll be talking about that in a minute. More collaborative supply chains. So the idea is that you work closer with your supply chains, and obviously that's been mentioned before. Additive manufacturing, rapid prototyping, obviously, yes, an important one. It's already been talked about a lot today. And also there are new ways to process materials and new materials. An interesting one, obviously, again, manufacturing your own materials. So this idea that if you can rapid prototype stuff from a more basic material, you basically reduce the cost of your stock, and you can make more variety of products. And this sort of leads into this ultra flexibility. The idea is that you have automation that can cope with greater variety. When I first started working in industry after I completed, when I was doing my PhD, we designed machines to make specific products in a specific range of sizes. We used very traditional mechanical mechanisms. Obviously, the idea is to move away from that and to have machines that are very flexible. So ultimately, robots that we can reprogram, reconfigure, and we can make huge variety of products and reconfigure the production lines as well, reuse the equipment, which is what sort of car industry do a bit now, is reuse the equipment to make different things. So you can react to changing markets, customer demands, and but not have to spend so much money and time and effort into creating a new production line. And yes, ultimate customization, again, something that's already mentioned today. We have the customer as a designer. Whether we're any good at designing is probably another matter, but that's the idea. So flexible manufacturing systems probably herald the idea that we could have factories that worked without people in them. So we refer to as a lights-out factory. And arguably we do, but not to the extent that we probably envisaged. We have factories that maybe we leave running overnight. We have, FMS systems, CNC machines that you can leave running oversight at night, and if there's a problem, they'll call you on your mobile phone. But generally speaking, we still very much have factories with people in them, working in them, and we can't get away from that. But do we want factories without people in them? So one of the other key things is that's often overlooked and not publicised anything like enough is the fact that using automation does increase employment. Obviously, the cartoon there I showed you earlier implied that, yes, you would be able to get rid of workers. And probably initially, a company implementing automation may reduce their workforce, but generally automation brings scales of efficiency and productivity, which means you become more successful, so therefore employment goes up, so it shouldn't be feared. International Federation of Robotics promotes this, but there are other case studies that demonstrate this to be the case, so we should make that clear. And the United Kingdom, again, there are many supporting research, including Industry 4.0, that basically says the UK has a lot to gain from having automation, probably the nature of the industries that we do have, high-value manufacturing, we still don't use enough automation and robotics, and there's a lot to be gained from that. And Borough had an initiative sponsored by the UK government to get consultants to go into industries to sort of demonstrate to companies how they could improve their manufacturing, improve their profitability by having more automation. Unfortunately, that funding was only available for a short time. It was very popular, very successful. It was a lot of work for their consultants, but it has come to an end, unfortunately. And they're really wishing that they could have some more of that, to do more of that. But it's not happening. It doesn't look like it's happening anytime soon. So, yeah, evolution, not revolution. Again, Industry 4.0 also coined that phrase. We develop things gradually. You think of things as sort of being a revolution and step changes, but actually things come about gradually. We take existing emerging technologies and adapt them and combine them to produce solutions for the real world. It doesn't just sort of happen very suddenly. So, yeah, I had to mention Industry 4.0. So this is, the Siemens slide, but this is sort of trying to summarise it up. We don't entirely agree with their version of the future, self-optimised cyber-physical, based on analysis of virtual models expressing options for action. I don't quite know where they got the cyber term from. It's a bit, science fiction, really, isn't it? I think it's what I would sort of debate now about that opinion of the future that we have, self-control, autonomy, basically, autonomy in machines. So this sort of tries to summarise the work of the Automation System Group in WMG. So we can create virtual factories. So this is build factories within a model, computer model. We can look at layouts of factories, not just in sort of terms of blocks, but also in terms of the physical kinematic models of the robots. This is where you see videos of the robots moving around. We can do all that, and that's what's done regularly now to produce highly automated production lines. And the work that the Automation Systems Group are doing is to then build on that information in terms of the deployment, so creating the physical version of that virtual factory. And the idea is that you can train, you can create the control systems, you can program the robots, program the computers to do what you want them to do. The ultimate aim is that the deployment is as painless and as efficient in terms of cost and time as much as possible. And generally what happens in industry is that once the production line is working, everybody clears off, leaves it to the person running the production line to get on with it. And all this information, the virtual factory, and everything sort of stops being used. And the idea is that really you probably need to think more long term. The idea is that you need to use that information and keep on using it. So, as I said, operator training, being able to train people how to support the production line. So, in terms of maintenance and service, and then ultimately, how you reconfigure it. Use that information to then reconfigure it to make something else or to improve your product. So that's what they're sort of working on. So areas then. Currently they have 8 researchers, and we're entirely driven, as most of WMG is, on user collaboration. We do what people in industry want us to do. So engineering lifecycle support, looking at supply chains as well, using this virtual module to see how we can integrate the supply chains into production lines. knowledge capture, this has always been talked about for a long time, but now we've got the best technology, the best software to capture that, and the idea is that you retain it and you reuse it in a way that people can understand it and reuse it and apply it again. Looking at sustainability, making more sustainable factories, maybe plan for that in advance by using these modules to look at how much energy you consume and whether you can improve that, optimizing what you do in terms of the process or the machine, being able to control it all, program it all, get it all working together in the best possible fashion without wasting loads of time doing that. This is a diagram we've put together to sort of show how that might work. So we've got the control in the middle, and the cloud at the top. That's the only mention I make of cloud computing, by the way, is this cloud. The idea is this: you have information feeding in from outside. I don't know what's the weather doing, maybe how you control your factory, your utilities. Also, your virtual commissioning that goes into programming your control systems, and goes out to setting up your production, managing your facilities, and what they're looking at is using Google Glasses to using your virtual factory to inform your maintenance or operators. They can walk around the factory, look through the glasses, and have extra information, augmented reality, to show them where to go and look for something, to fix it, to check on something. So that's what we're sort of predicting for the future. And we don't just sort of talk about this stuff, we do build this as well. We have our automation systems demonstrator within our workshop, and we try out these new ideas physically. So it's a little production line with robots and everything, conveyors, and we test it out for real. So another thing is this idea of machine to machine. So if you could put a communication microprocessor, obviously all machines have got microprocessors in now, if you could get them to communicate that data between each other, what do you do with all that data? You could sort of argue it's this big data for factories. The idea is that we have the internet, it produces lots of information, we then try and use it for something useful, to find out very useful things in a way that we could never do before. That would have cost a lot of money and taken a lot of time. Now it doesn't. And we could stick a smartphone in a machine and get it to call you up and tell you lots of interesting things. Some of the time you don't need that level of technology. You can just put a simple processor, one that we get kids to use, Arduino chips, into some things, and you just need a simple signal. So the challenge is to use this data and maybe to decide how much autonomy you use to process it, or a large amount of information. You don't want to be sorting through it. It's going to be generated in real time. You want to have an automation system, autonomy, to sort of sort it into something meaningful, to give you some meaningful information, and then to act on it. And the decision is, do you get the machines to act on it automatically, or do you put a person in that loop? I'd like to think we have some human involvement in there somewhere. We're at a point now where we can decide how much autonomy we want in our machines, and we already do have it. It's very low-level control, but there is autonomy in machines. They do set themselves up to some extent. It's just a question of how much do you want them to do that. Going back to our other areas in WMG, cybersecurity, there's only been really one reported case of an attack from outside into a control system, but yes, there's a huge potential threat, possibly from governments at the moment, but it could be any organisation. How do we protect our factories, particularly the ones that handle the chemicals, the nuclear? How do you protect them? So thinking of the customer then as a designer, if we can have very flexible manufacturing techniques, additive layer technology, we have the internet to convey large amounts of information and to deliver large amounts of information. What do we do with all that? Well, we can have our customers as a designer. We can make bespoke parts to people's preferences. For some reason at WMG they call it the hub of all things. I suppose it's to imply that it's not just the internet, but there's people involved as well, physical things as well. So yes, we're looking at using additive layer technology. We're researching it. I always used to sort of dismiss it because obviously I build stuff as well, and we're always a little bit disappointed when we get our components from the rapid prototyping machines, that they're never quite the right size that we want them to be or quite the right strength. But they are looking at doing new materials. One of the research projects we've got with one of my former students is looking at nickel-based super alloys. So the idea is that, yes, we will hopefully have additive layer manufacturing with better materials that we can really use. And, yeah, reconfigurable production lines to sort of get the customer, to make what the customer wants in a very flexible and efficient way, and very quickly without too much human involvement. So what are the drivers for robotics research in the UK? Well, this is my area of interest. It's not really in the factory. There's not much money, certainly from the government, to carry out in the factory. The main robot manufacturers are actually in Europe, possibly Japan as well, and Korea. But yes, Europe, not necessarily the UK. Generally, we have service centres here. So the drivers really are what the sort of, as a nation or a population, we feel we need things like assisted living. So I've got what's called a giraffe, which is a remote telepresence taken here at the NEC a few years ago. Yeah, it's nothing special really, but it just illustrates the point. Autonomy in vehicles, that's going to be a big driver because, let's face it, we all have cars, we all spend a lot of money on our cars, and this could answer a lot of problems in terms of safety and being able to keep our roads uncongested and keep our transport system going in a more efficient and cheap way without having to do massive infrastructure changes, that we can get vehicles to navigate our roads exactly as they are. And the sensor technology that you need to do that is incredibly expensive at the moment. But obviously, if there's a demand for that, then it's going to push the price down. So we use what we call cameras, obviously just cameras that you normally get on a car, but we also use LiDAR, which is light radar, is the way I would describe it in layman's terms. They're quite expensive at the moment, but huge applications. So we're turning cars into robots, basically. And you have to decide really as a world how much autonomy we want in these vehicles, because obviously we now have them navigating roads with cars moving around, and they can stop and deal with situations very quickly. They're incredibly expensive at the moment, but this is the sort of thing we have to ask ourselves: how much autonomy do we want? Do we want full autonomy and we just passengers in these cars, or do we want it to be? Do we want to still be in control? And yeah, this is driven by the sensor technology. So it's obviously interesting what we were saying earlier about the fact that we're creating these parts, but we don't really know how to make sure that they have the integrity and the quality, and we can assure that quality. Obviously, sensor technology is probably the thing that's sort of holding us back in terms of applying this technology. So one year, students decided that when the Xbox Kinect came out, that they would stick it on a robot and see if they could get it to sort of work. And this robot is built by students, and the idea is that it's supposed to be autonomous. We never actually got that far, but supposed to be autonomous, and we're supposed to use it to find victims in disaster zones where it's too unsafe to send humans. So it's sort of got a very important purpose. So this sensor technology, the great thing about it is that it's very sophisticated, but because it's been designed for the gaming industry, it's cheap, mass-produced, cheap, and reliable. So we can sort of use it in ways that we never thought we could because it's so cheap. We can have lots of it, and so on. So yeah, I have a group called Warwick Mobile Robotics. It's basically lots of student projects, PhDs, and undergraduate. And we look at various things that we've looked at, which is the unmanned search and rescue robots. So this and the previous one were designed by undergraduate students. We take it to a competition, international competitions, and they compete with the best in the world. And this is where we're pioneering mobile robotics. Really, it's sort of where we sort of have the competitions, and it drives forward ideas and knowledge. And from that, we had a project with Sellafield Nuclear Decommissioning to create an aerial inspection robot. So the idea is, legacy of the Cold War, you have buildings that you don't really want to send people into. So the idea is that you send in robots to investigate what's in there, to take information and then report back. Again, how much autonomy do you really want? Do you want the robot to decide that, yes, it would be a really good idea to fly around this potentially radioactive building and then fly back out to you and cover you in radiation? No, you don't. So it's a semi-autonomous. So the idea is that it doesn't crash into things. It takes over when you try and fly it into something. It sort of takes control so that it's easy to fly. If you've ever tried to fly one of these things, any little, toy helicopters or anything, they're incredibly difficult to fly. You usually end up crashing them. This one's worth about 7 to 10 grand, not because of the fact that it's got 6 blades. It's simply because of the sensor technology on there. And yes, that is a GoPro, by the way. So the idea is, yes, you don't want autonomy. We could make it autonomous, but why would we want to? Because if you send it into a building, you go, that looks interesting over there. Go and look at that. You want to be in command. You want to be in the mission command. So, and there's another project that I had with Land Rover. Was the idea is that they have lovely cars with lots of cameras on them. It would be nice that they use some slightly more interesting things than just helping you to park your Land Rover. So the idea was to look at using the cameras on the cars to process the information you get from them, to basically semantically label the scene the car sees, and to be able to recognise where the roads are, where the pavement is, and more importantly, where the obstacles are in front, like if somebody steps out in front of you. So that's sort of where that research is going. So coming back to the factory then, taking robots out of the factory, I'd like to think that the technology that we're advancing to get robots to interact with the real world, which is unpredictable and highly variable, unlike a factory. In an automation factory, we design them to be very predictable, very rigid, so that we don't need this flexibility much. So the idea is that maybe we could have robots that collaborate with humans, that they work alongside them. At the moment, they're all behind barriers because it's dangerous. We keep everybody apart. But the robots are very good in terms of doing repetitive, boring tasks that are dull and dangerous, where you require a lot of strength. But humans are also very good at making complex decisions and doing complex manipulation. So if you could have the two working together, then side by side, then that's your factory of the future, really. And again, this is an image that the students took with Xbox, I think it was. It shows obviously quite clearly, you can see the human in the picture there, is that if this technology could be advanced, and it's cheap, this is 100 quid, or it's probably less than that now, you could use this information to make the robot aware that there is a human, where they are in the room, what they're doing, and ensure that there's safety there to make sure these systems are safe. So we developed this idea that there are 4 levels of robot sophistication. The first one being that a robot has no ability, it just assumes that something's there and it goes and picks it up. Second being simple sensory feedback. The third one is sort of where we're currently at, where we use cameras and complex sensory feedback, so using many sensors and fusing that information together to sort of create some sort of meaning. Feed it back to the robot so they can deal with environments where there are some unpredictability. But what we really want to aim for is the 4th level, which is the autonomous vehicles. In a factory sense, that will be robots handling flexible materials. So if you ever get a chance to go around the factories, the automotive factories, which use the most automation, it's certainly this is the case in this country. You'll see wall-to-wall automation at the start, making the car bodies, dealing with the solid metal, welding them together and so forth. But when you get towards the end of the production line, when it comes to putting in the harnesses, the carpets and stuff, dealing with the flexible materials, that's still very much done by hand. So we would want to see more automation to be able to do that. And the best photo I could come up with was, obviously, have to mention football today, of all days. We have our robotic football team here. And the idea is that in Rio next month, it won't just be humans playing football, it's going to be robots as well. And the intention is to get a robot team. 2050, they are predicting that a team of robots will be able to beat the World Cup team. Not sure I'd want to be in that World Cup team. The human one anyway. At the moment, as you probably this picture the students took quite nicely illustrates that the robots probably have the ability of a 5-year-old to play football. I see them falling over all over the place. But unfortunately, Warwick doesn't have a team anymore. We're not sending a team to the World Cup. But I've just read in the paper today on the train that Plymouth are. So good on Plymouth. So yes, being able to deal with a ball very quickly, rolling around a football pitch, and not to mention all the other players coming to tackle you. That's the sort of intention we're trying to move towards. So that's talking about the robots and the automation in the factory. We need to put people in there as well. I've sort of established the fact that we don't have a factory without people. We need people in there as well. It's a no-brainer that we need a highly skilled workforce, and they need to have a multidisciplinary set of skills. We can't just have mechanical engineers, electronics engineers. We need engineers with lots of a combination of these skills. We need people to be IT illiterate. Thankfully, UK schools from September are going to be teaching programming, not just in senior schools, but in primary schools as well. Obviously, we need lots of people with robotics skills, and that's been my job to impart that knowledge for many years now. Thankfully, we are having increasing numbers of students doing apprenticeships, and we're also having increasing numbers of students studying engineering. But the problem is that we're very well aware of at Warwick is that industry needs to attract and retain those students. We have a very good business school at Warwick, and obviously people come to recruit from that. They don't just come to recruit from the business school. They're very keen to employ the engineers as well. We have quite a lot of very good students who go and work in the city for much bigger salaries. And I suppose if you're coming out with a massive debt, that's going to be even more attractive in the future. So think of that as employees. That's who you're competing against. Unfortunately, though, to end on a sad note, manufacturing graduates are at an all-time low. I could put figures and graphs on here and I used to, but it's too depressing. It's too depressing, and I think it makes the situation worse. So I am not going to quote figures, but it's woefully low in this country. I'd like to think that maybe the number of inquiries I've had in my office in the last few weeks and months is more about manufacturing, because I'm in charge of our manufacturing degree, the undergraduate ones. Has increased this year more than any other years, and maybe the tide is turning, but at the moment trying to persuade students to come and study manufacturing engineering at degree level is a very much a lost cause. We have an open day tomorrow, and I'm going to be talking at it, but I'm going to be talking about automotive engineering. I am. I'm going to be encouraging people to study automotive engineering. The great thing is that we put lots of courses in there that have manufacturing in them. So they're actually studying quite a lot of manufacturing. But yeah, we appeal to the market, and Sophie said earlier about the lack of materials engineers. We could teach wonderful master's courses in materials engineering at Warwick because we have the people to do it. It's just that there is no demand. Internationally, the majority of the students that we have studying our courses overseas, and here in the UK, it's about business management, supply chain, it's about the business end. They're not really so much interested in the technical end. Undergraduate, it's not so bad, but that's what they want to study. So we are trying to address this problem. WMG are opening Academy for Young Engineers this September. So this is for 14 to 19-year-olds. We have multidisciplinary engineering courses. That's all you can study at Warwick. So you do general engineering the first 2 years, then you specialise, possibly in manufacturing if you want. And that's the only way we can make our manufacturing courses viable. We also have a full-time and part-time master's programmes, many of them. And we also have professional programmes as well that we do for industry. So if you ever want any, come to me, ask me. We have our International Doctoral Centre as well, NGDs, as well as PhDs. And we do a lot of outreach. This is a nice student project I had this year. The third-year engineer who developed this little mini version for schools. So we get a lot of inquiries from schools because we have the aerial robots. So we thought we'd do a mini version for school kids to play with. So thank you, and please feel free to ask me any questions.